17.2, here we go, starting at the very bottom of 452. Now, this sticky note you should already have in your book. We've talked about this one already, about the hurricanes and stuff. All right, so the sticky note for 452, starts right here. Air pollutants. So there's a difference between air pollutants and air pollution. It's real subtle, but basically air pollutants are the things in the air, like the particulates. Those are what's called the pollutants. You know, gases, particulate matter from the atmosphere, so on and so on. Now, air pollution is basically the process of releasing air pollutants. So they're a little bit different from each other, but they do have a difference. So make sure you know the difference between them if in case the test asks about the difference or uses them in different contexts. So outdoor air pollution is also a thing called ambient air pollution, is what that stuff is called. Now, this outdoor air pollution, this is the stuff that affects climate change, but also in a much more real sense, 3.3 million people die annually prematurely because of it. And this prematurely thing can be honestly as simple as like 3 or 4 years, or it can be as extreme as like 30 years because of this stuff. But it's just simply saying that people are dying before they naturally would have if they weren't exposed to those pollutants. So 453, I'll zoom in a little bit here because I wrote small. So air pollution can be natural. You know, like there's some plants in the Blue Ridge Mountains. The Blue Ridge Mountains are over like on the eastern coast, like between like kind of like Maryland and northern Georgia. Some of those plants emit pollutants that basically kind of like turn the air blue over. That's where they get the name Blue Ridge Mountains. So you can have primary pollution and secondary pollution, or primary pollutants and secondary pollutants. So the primary one would be like pollution from a factory. Very straightforward. You know, you got a factory making a bunch of stuff that's spewing out pollution. The secondary aspect of this is basically the pollution goes into the atmosphere, mixes with things, and makes acid rain. That's the secondary type of pollution. It starts from the source and then creates another type of pollution. So like oil spill from a tanker, that can cause, once it kind of moves into the rivers, and it can like react with the thing that's already in the rivers and create eutrophication, or basically an algal bloom, kind of like too much nitrogen and too much nutrients go on in the rivers. Now, there's also a thing that they talk about called residence time. What that is how long things are going to stay around in the air, how long it's going to take for them to kind of like get like dispersed, think of it that way. But it's like how long it's going to live there, causing problems. So the short time, it changes daily. You know, you think about like it's a smoggy day in Seattle, and then the next day, everything's fine. That's short residence time. But a longer residence time, that can affect like the region or even globally. So, you know, like they got a picture of, excuse me, they got a picture there of like Mount St. Helens. That was most definitely a big regional thing that was going on. All those pollutants spilling out or spewing out got moved everywhere. Now the thing there, the dust storm, the picture to the right there, see the dust storm blowing dust from Africa to the Americas? Basically it's moving over. And I'm not sure if you guys seen, but there's a lot of dust that's actually moving into Europe from the Sahara Desert these days. Like I saw a picture the other day that there was snow, or excuse me, there was dust from the Sahara on top of the snow in Europe. And that's what they're talking about with pollutants moving around. So now I talked about it real briefly at the beginning of class today, but a thing called the Clean Air Act. So this was passed in 1970. The Clean Air Act is the chief law controlling air pollution. So it monitors 6 of the major pollutants, and we're going to talk about each of them real quick. But you can see there they are. There's carbon monoxide, sulfur dioxide, nitrogen oxide, volatile organic compounds, which there's a huge list of those guys. Then there's particulate matter, and there's also lead. And lead leads to neurological diseases, and this is actually like the pushback from that led to unleaded gasoline. Like if you go to the gas station, there's no chance you're getting leaded gasoline because they figured out it obviously causes neurological damage, so they got to get rid of it. So carbon monoxide, I'm not sure if you ever heard about the commercials to get a CO monitor or carbon monoxide monitor in your house. They always talk about, and it says it right there, it's a colorless, odorless gas. So primarily, you can see the second part says produced primarily by the incomplete combustion of fuel. So think about like if you have like a natural gas furnace, potentially a bunch of carbon monoxide is going to get into your house, and that's why they have those carbon monoxide detectors. Because you're just unfortunately, there's stories all the time that there wasn't a carbon monoxide detector, and simply a family just went to sleep at nighttime and then got carbon monoxide poisoning, and then they perished that night, unfortunately. Sulfur dioxide has a very pungent odor. I'm not sure if you ever smelled sulfur, but it's rank. You're never going to mistake that one. So sulfur dioxide is one of the things that can get into the atmosphere, and that can cause acid rain, which is real bad. Nitrous oxides, same general idea. It can basically cause it can cause acid rain. That's coming typically from carbon, or excuse me, from cars. Volatile organic compounds. So now this one, so you can see at the very top, they're carbon-containing chemicals emitted by vehicle engines in a wide variety of solvents, industrial processes, household chemicals, and consumer items. So there's a whole bunch of these things. So, but because they kind of leave it open-ended, because they're worried about like basically kind of anything that can make that secondary pollutant, that can be one of these things. And like I talked about the Blue Ridge Mountain right there, the remainder comes from natural sources. For example, plants produce isoprene and terpenes, compounds that generate a bluish haze that has given the Blue Ridge Mountains their name. That's what I was talking about earlier. Now, particulate matter, that's what we're actually going to start testing for today. Basically just things that are in the air, dust and soot and pollen and dander and stuff like that. Then lead, we obviously got lead at the bottom. Now, the thing I'm talking about here is that pollutant emissions have dropped while population has increased, which is actually kind of, think of it almost as a success story. So the policy that was enacted, like the Clean Air Act, as well as technological advances, were driven by grassroots movements. So legitimately, people were mad that the air quality in their neighborhood was bad, and they just signed on. They basically pushed the EPA and the government to do something about it. So these two charts over here, I'll zoom out just a little bit. These two charts over here basically show what's going on. So let's start at the bottom, actually. So you can see emissions, they're going down. But look how energy consumption, that's gone up. The population has gone up. The vehicles' miles of travel has really gone up, and the GDP has also gone up. So all these things have gone up, but look at the trend of all this stuff. It's gone down a lot. Like you can see, carbon monoxide is down 72%. And you can see the different things that are going on. This here, this is the lead, has gone down 99%. It's actually on a different y-axis than these guys. That's why you don't see the big tall ones there. So you can see real big tall, and it's really tiny right there. So it's basically all of these things have gone down drastically, while all the things that kind of like quote unquote make our society good has gone up. We're consuming more energy, our population has gone up, we're driving more, our country's success and financially has gone up a lot, but yet we're still putting out less and less and less pollution, which is really good. Some of those technological advances are these things right here. Okay, the thing I talk about is the scrubbers and bag house filters. So the new technology, like it says there, has helped pollutants be captured much better. So I'm going to leave it here for a quick second. On this page on 456 has two pictures of these things. So the first one is a scrubber, is what this guy is here. I'll zoom out a little bit more, sorry. So a scrubber is basically, so as this, the dirty fuel gas enters the scrubber, basically they're pushing the gas will rise, and eventually it's going to go out, but they're pumping in a whole bunch of water. They mix it sometimes with like lime or a bunch of some other chemicals. So as it rains down, it basically kind of like grabs the dirty particles and it goes down here. They filter it all out, and you can see it says dispose of as hazardous waste. So they're ensuring that this stuff doesn't get out into the atmosphere, which is really, 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 really good. They also have things in cars. Talk about the catalytic converter. I'm not sure if you've ever heard about that. It's basically kind of like a honeycomb looking structure that basically filters everything as it's starting to go out of the car to make the exhaust from cars cleaner. Obviously, it's not perfect, but it's much better than it was. So now nitrogen dioxide, this is on 457. This is a reddish brown coloration, and it smells really bad. So have you ever been in like LA on a smoggy day? just kind of has a stench to it. That's what you're smelling, is this nitrogen dioxide. There's also tropospheric ozone, which is ground level ozone. That comes mainly from motor vehicles, is what that is. This O3 is what that's in the little parentheses there if you can't read it. Now, like I've said a few different times, air quality has improved, like I showed the chart just a few seconds ago. But there are still hotspots like LA County, and there's a diagram I'm going to show you here in a couple seconds about that. So now in 2014, so granted this is 5-6 years ago, 57 million Americans lived in hotspots because, and we've talked about this before, a lot of Americans are packing into the urban areas, and urban areas is typically where air quality is the worst. We'll talk about the rural area in just a couple seconds, but typically the urban areas is where this stuff is the worst. Now there's also, it says here, toxic pollutants are monitored more closely since they are known to cause major health problems. So like lead would have been one of them before the Clean Air Act was enacted. Now the picture I was just referring to, or excuse me, the diagram about LA County is this. So you can see the caption of this bad boy says, in most U.S. cities, air is becoming cleaner. So look at the legend, 1985, 1995, 2005, 2015. So the number of days with unhealthy air by year. So like look at Houston. It started off high in 1985, dropped a little bit, dropped a bunch to 2005, dropped a bunch to 2015. So they only have 32 days the whole year that have bad air quality. Jump up to us. Look at that drop from 85 to 95 in 10 years. Look how much significance has dropped there. Look at Cleveland. You know, going down, going down, going down, and then just significant drop in the last 10 years, or the 2005 to 2015. New York, same thing. Really bad air, and they've really cleaned it up. But look at LA. They are improving, and trends is what we like in science. It's not just one random data point. The trend is what we're worried about. They are coming down. They're still at 106 bad days, which if you look over this whole thing, it's really high comparatively, but LA is declining, which is what we want. They're making strides, and that's what we're looking for. Now, I talked about urban areas are bad, but rural areas also have issues with air quality as well. So they use a lot of pesticides, and pesticides are typically a spray, and so they're aerosolized, so they can get into the air. Then feedlots, which we've talked about before, you know, a whole bunch of cattle or chicken or pigs or whatever they are, that's kind of stuffed into a small place, they generate a lot of methane. They also generate hydrogen sulfide and ammonia. All of those increase lung disease. You know, like methane. Methane is one of really, really powerful greenhouse gas. You know, like cattle burp out methane, cows burp out methane a lot. Now, developing countries, they have really bad air quality because they're choosing expansion and GDP, or they're basically the wealth of the nation. They're choosing that over their air quality, which is unfortunate. Plus, to basically control the air quality, it does take money to regulate that stuff and develop the technology and pay for the technology. Because it's just more expensive than just simply burning fuel. It's a cheaper way to have expansion go more. Now, I didn't write anything on page 459 here, but you can see the two pictures up top. So you can see Tiananmen Square in Beijing. I was actually in Beijing a couple years ago, and I remember it being hazy. In Delhi, India, same thing. You can see it's rated as having the poorest air quality in the world. They've talked about living there is the equivalent to smoking 3 packs of cigarettes a day because the air quality is so poor. All right, moving to 462. So, industrial smog, like the name implies, it's from factories. Okay, there's also a thing called the photochemical smog. These are from cars mixed with sunlight. This happens with more, or it causes more of an issue when there's what's called a temperature inversion. So, it should be like this, where basically there's warm air on the bottom, the warm air rises, gets cool as it goes up. However, in the city, sometimes everything kind of gets mixed up. So like the warm air rises, but kind of gets stuck, and then cool air gets underneath it, and so that warm pocket just kind of gets stuck there. And that's where the smog is going to live, is in that warm packet, or that warm pocket, excuse me. So like you can see here, you can see Donora, Pennsylvania, midday in 1948. That's what's going on. basically the smog from the factories has moved over towards the city, is what's going on. Okay? LA, this is talking about the photochemical smog. I'll zoom out just a little bit. Okay, this is what's happened in LA. You got a whole bunch of fuel coming out of cars. You got the volatile organic compounds coming out of cars. You got nitrous oxide, nitrogen dioxide. They all kind of come up here and they all start mixing together and making those secondary pollutants. They get stuck in the atmosphere, and that's what creates the smog over LA. All right. So the last part, I didn't actually put any sticky notes here. I kind of wanted to leave it a little bit more open-ended per se. It says, should we regulate greenhouse gases as air pollutants? So obviously, in my opinion, yeah, we definitely need to. Which Obama's administration, the EPA, they did. They did start categorizing them as air pollutants. So a bunch of states started suing. The appeals court, Obama's administration, the EPA won that. However, like it says on the top of page 465 here, let's zoom in so we can read it. A number of industries and states soon lined up to challenge the plan in court. And in 2016, the Supreme Court issued a stay of the plan. A stay basically means, and like it says it right there, preventing the EPA from enforcing. It basically means that, hey, you can't put it into effect just yet, is what that stay means. Excuse me. So that's basically what was going on with the EPA trying to do that. And then, like I talked about real briefly today, the Trump administration kind of dialed back the Clean Air Act a little bit. This is part of the stuff that they were kind of dialing back, kind of like the power of the EPA to do stuff. Whereas Biden's administration is kind of trying to ramp that up. So the interesting thing is that it says a lot of industries. I'm not sure if you've heard, but like Ford and GM are basically going 100% electric. And this comes from not only realizing that, oh, Biden's a Democrat, he's got this big thing on climate change, but it's that grassroots movement. There's a much more push for those hybrid and electric vehicles from the public, so the private sector is responding to that pressure to basically make more money, and that's where they're coming from, and that's what they're bending to. So leave some questions, we have stuff to talk about.